trap. What's the screening trap? The fact that you screen 1,000 people, for example, now for diabetes, 150 of them tested positive. Your report says, okay, you have 50% and 15% prevalence. Is this accurate? It actually depends. It depends on several factors. Was your screening test perfect? The reality of screening tests is that sensitivity, that's the true positive rate. All these things, we'll be talking about them soon, and we'll be talking about the sensitivity and specificity. These are the critical aspects of screening. Yeah. Or I think later in the this thing we'll be talking much about them. These are actually things that are very important, even in data science. Also, when we are talking about evaluation of models for predicting whatever things that you are trying to predict, and it helps you to test how powerful certain test is, even diagnostic test, the sensitivity, the specificity, the positive predictive value, the negative predictive value, and whatnot and whatnot. The understanding of these things are actually key to how powerful your test is. So yes, so we have sensitivity and specificity. What sensitivity intends to do is to say that if this disease is is there, if this disease is there, how often can you sense that is there? That's the sensitivity. But specificity is that if the disease is there, how sure are you that the disease is there? Yes, that's how you know specificity. Sensitivity can say, okay, oftentimes I know if I say oftentimes I know it will know that the disease is there. But the shorty is now when we talk about specificity. So if you say this disease is there, if I say if the test say this disease is there, how sure are you is specificity? Well, sensitivity is that if the disease is there, I will most likely know the disease is there. That's sensitivity. But if you know, if you want to read further on this, you can read further on this. But I know later in this course we actually be deep diving into this. So yes. Now the specificity and sensitivity uh, is largely determined. Like most of your screening tests, the reason behind it, the objective behind the disease will make you know what is right for you in terms of the screening. So you can't just use prevalence as your this thing, or else you enter that trap. But we use you now try to use sensitivity and specificity. So true prevalence might differ from apparent prevalence. So prevalence in dynamic population. So for example, we have HIV prevalence appears to decrease in a community. That's a good news. Not necessarily. There are three explanations. There is true decrease. Number two, there is increased mortality, or there is increased migration. So yes, so if you say okay, this prevalence is decreasing, you want to really be sure that these are just factors for us to understand when we are dealing with this. We've talked about that of incident, and currently we are talking about that of the prevalence. Now, also always remember that prevalence is incidence times the duration of the disease. So mortality measures. So mortality measures, beyond the basics, we have certain measures that we ought to also look into that are important in epidemiology. For example, specific mortality rates. Yes, we have age specific, sex specific, and so on and so forth. Then, yes, age specific is important for target population. For example, if country A can have higher crude mortality, and what is the crude mortality? That has not been specific. You are just saying all the total population. You are using all the total population for certain disease mortality. But for country A can have higher crude mortality than country B, but it actually can differ in age. So when you calculate the age specific, you now know the effect on particular age group. Yes, infant mortality. That's the reason why we talk about infant mortality rate, perinatal mortality rate, neonatal mortality rate, and so on and so on and so forth, so that we can know age-specific mortality rate. For example, infant mortality rate is one of the most critical factors to actually measure the socio-economic trend in a community. So yes. So also age standardized mortality rates allows for fair comparison between populations um, with different age structures. So, and what do? We calculate the age specific rate for a population, then we apply this rate to a standard population, usually the WHO standard or whatever standard that you are comparing, and then you sum the rate. So we do this practical, especially this one. Let me even mark it. Next time when we are doing practical, we could look into this age specific mortality rate. Yes, and we see how we can do it on Excel. Then years of potential life loss. So this we are beginning to come into area where it's very important because in this thing we look at disability adjusted we look at disability um, adjusted life years, and when we are looking at it there are some these things that are critical to it like YLL and other factors. So the years of potential life lost, yes, is for us to be able to look at you able to calculate, it helps us to be able to calculate the years that have been lost by the fact that this disease came in and there is death from the diseases. So, for example, which is what? For example, we have a question here. We say, which is what? 10 deaths at age 80 or 5 deaths at age 25? It depends on perspective. So when we use our calculation for years of potential life, we choose a reference age. Yes, more often than not, the reference rate that is usually used is to use the um, um, I think average age of living, yes, for a particular country, or we can use that, or you can also choose your own reference. So choose a reference age. So we say that okay, 75 years is the reference age. Then for each death, you calculate the years lost. So it's 75 minus each at death. So you sum all the years lost. So we have one example here. So the age of death is 25. The years lost as 75 as our references is 50 for 25, 30, 45 for 30, 47 for 28. Then we we had everything. So 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 we now realize that year of potential life lost, years of potential life loss increases as we have the increase in death of at younger age, and this is useful for prioritizing certain intervention, especially for example in road accidents versus age-related disease. So then we talk about advanced case fatality rate. We have advanced case fatality rate. We have time dependent case fatality rate. So, for example, we have in outbreak, early case fatality rate estimate of is often wrong. For example, Ebola outbreak by the 10, 100 has been confirmed cases, then 20 are dead, then case fatality rate will be 20 over 100. But wait, 50 of those 100 are still sick and might die. So that's the reason why we now have adjusted case fatality rate, which is death over death plus recovered. Yes, this is, okay, let me put this as red. Uh, oh, yes. So this is 50. Yeah. So which gives us 40%. We now see that there's a large difference between 20% and 40%. This one is assuming that 30 recovered and 50 is still sick. So early outbreak of earlier outbreak, the case fatality rates from early outbreak is often as bad. That's the reason why we have to track it over time for us to see, um, for us to get the right, right to have the right insight from the calculation. Then we have case fatality rate and the infection fatality rate. So for case fatality rate, your denominator is the confirmed rate, confirmed cases. Why for infection fatality rate, all those who are infected, including asymptomatic, are the ones that you are targeting as the denominator. Why the numerator for both is actually the cases that are dead. Yes. So for COVID-19, for example, the case fatality rate is 2 to 3% based on the confirmed cases, while the infection fatality rate is 0.5 to 1%. So we have an example here. We have an example here that we can use to calculate. Yes, I expect this exercise as part of the assignment. As part of the assignment. Yes, and I will say it is important for you to do this exercise, and that's how these things can actually. That's where that these things can actually um will actually settle. You can actually consolidate most of the things that we are talking about here. So yes, most of the things that we are talking about here. So you can just use this to calculate monthly point prevalence, monthly incidence, cumulative incidence, the case fatality rate and mortality rate. So yeah, now we go to session 6. It gives us, if there is any question you have from this session, you can drop it in the you can drop it on the group, and it will be attended to. And please, I would say that your questions will actually guide how we move on to the next. We guide what area we should focus on the practical life session. Yeah, so we now go to section 6, and in section 6 we'll be talking about the ratio, we're talking about proportions and rates. So, and of course, first thing you must do is first understand the difference between rates, ratio, and proportion. First, ratio is the comparison between two quantities which the numerator is not part of the denominator. Yes, numerator is not part of the denominator. Numerator is not part of denominator. However, in proportion, the numerator is part of the denominator. You see the technical difference? Yes. Yeah. Now rates now add time dimensions to a proportion. That's just the difference. Ratio, numerator is not part of the numerator. For example, male to female ratio. Male are not part of female. That means that is a ratio. Yes. But if we say male in a population, the male population out of um, the data analyst in Ilorin, for example, that's a proportion. And then when we now say between this time and this time, what is the okay, within this time and this time, what is the rate? Or where we say for each month, how many female data analysts do we have in a specific? It becomes a rate. Say in entire years per month, how many? Yeah. So that's when you begin to add time dimension to um, to your to your proportion. So let's just explain using this example. So okay, I've used sex ratio as an example. Then you will have heard something around doctor to patient ratio. Yes, typical. Yes, when we begin to have one doctor to 10,000, you know that that ratio is telling us that we need to do something fast. Yes, when we are expecting that is one doctor to 200 patients, we already have moving one doctor to 10,000 patients. So these are the things that we must give attention. The dependency ratio, for example, the dependent, that's dependent population to the working population. But who are the dependent population? Is the children, children between the age I think 0 to 15, and adults beyond the age of 65. That's dependent. Then we now have working age. That's between 15 to 64. So that's working age. So when we use, because they are not no, they are not intersecting at any point to become a ratio. So, but for proportion, the numerator is part of the denominator. So I've used this as an example. Proportion of female among data analysts in Ilorin. So we can use that. Then proportion vaccinated. Then we say attack rate. Attack rate is actually a proportion. You should know that. Let me help you paint it red so that we can check that. Because put it red. Yes. Yes. Because what you calculate is 50 out of 200. Yeah. So yes, you using set. Using set, you see numerator is part of denominator. Is a subset. Let me use the mathematical word. Is a subset of the denominator. So rate. So rate, like I mentioned, is when you add time dimension to proportion. So it measures how fast something occurs. For example, what's birth rate? So we have 25 births per 1,000 population per year. 25 births per 1,000 population per year. That per year makes it a time dimension. Then we have 10 cases per 500 person years. That year make it a rate. Then 8 deaths per 1,000 population in a year. That rate make it that year make it a rate. So always there is a time component, either day, year, or month, or person time. All right. So a common epidemiological ratio, we have maternal mortality ratio. Yes, when you measure the maternal death. So when you maternal death over live birth times 100,000, so you can calculate the birth in 100,000. So it's not called rate, even though it's sometimes reported as maternal mortality rate. So we should take note of that. Then stillbirth rate is also actually a ratio, and these terms can be so confusing because of the fact that they are calling them rates when this should be called ratio. So stillbirth over live birth plus stillbirth. So stillbirth over total birth, including both stillbirth and live birth, times 1,000. So it's the ratio. So I'm looking at something here and it's a little, I'm trying to figure. So this should be a proportion. I will look into this. This should be, this should be a proportion. This should be a proportion. This should be a proportion. I will look into it and get back. Then we have infant mortality rate. So the infant mortality rate is infant death less than 1 year over, over live birth. Over live birth. Over live birth. Yes. Infant death less than over live birth. That's infant mortality rate. And if we look at it, the numerator is not the denominator, makes it a ratio. Alright, so sometimes these things can be a little bit confusing, but it's important to check that this to understand the concept of rate, ratio, and proportion. Yeah. So it's important to understand the concept of rate, ratio, and proportion. Then there are different school of thought around specific ones, which sometimes, if you use the definition, is actually the rate, and some the is proportion or ratio. Like for example, the infant mortality rate, some people call it rate, some people call it a ratio. But if you deep dive into it, you understand that the live births are not exactly part of the infant's death. They're actually different. Yes, and it should be a ratio. For another example is that another example is under five mortality rate. Mortality rate, as much as it's called rate, mortality rate. If you look at the children under five, um, some part of this one should be more of a proportion. If you look at the definition, these are the dynamics that are around most of these rates and ratio. But typically, it is generally admitted that maternal mortality rate is actually a proportion. Yes. Yeah, other proportion that you should know is the prevalence rate. Yeah, is the prevalence. So, yeah. Fertility measures, we measure fertility using crude birth rate, and total fertility rate, and what else? Yes. So, crude birth rate is live birth in year divided by mid-year population. So, and yeah, mid-year population. So you have a calculation here that you can look at. But this is the formula. Then we have the general fertility rate, which is live births divided by women aged 15 to 49 times 1,000. Yes, more. This is more specific than the crude birth rate because only women of reproductive age are in the denominator. Then we have total fertility rate, which is the average number of children the woman would have in her lifetime if current age specific fertility rate remains constant, and it is calculated this way. Okay, for Nigeria, the total fertility rate in 2018, according to the DHF, is 5.3. On average, it means Nigerian women have 5.3 children. So this is another practice exercise for us for this. Yeah. So we have indicators and we have the count of them. So if you want to find the sex ratio, we use B3 over B4. What's B3? Is B3. Okay, I will, maybe in the next this thing, let me use this as an exercise for us to practice what we've been talking about in the lesson, in the practical session. However, it's something I would prefer that you go through, and by the next session, you will understand what we are actually doing. Yeah. So, what else? Yeah. Then we have common mistakes that is usually being made using the wrong multiplier. Yes, using the wrong multiplier, mixing up numerators, or using the wrong denominator. That's the common this thing. So this, I will be expecting this as my assignment for the next session. And like I mentioned, it is important for us to do this assignment and report back before the next session, the practical session, as it will guide the practical session on the dynamics and where to focus on during the practical session. So this will be the end of this theoretical didactic lecture. Then we'll be having a live session for the practical session. Thank you.